Okay, out there, the dude here talking about other ways of doing Operation 2. Let's just review Operation 1 real quick. This is a Titan 4M, a triangular part, and it's going to do a quick simulation. And I'm just going to bring it, if you use this last one, I'll bring it right to the end. I have it colorized right now by operation, or you can do by tool, or by comparison. Comparison is like compared to the model. And actually, I noticed on this one, left a little blue in there. And we had to look at the radius, and the radius was, I think, it's 378 divided by 2. So the radiuses was slightly larger than the tool, but we've accepted that as being intolerance. So, all right, so in reality, we're left with this. We're going to make a soft jaw that's like a triangle shape, clamp on it, and we got to machine the back off. Unlike the other ones, this is a big chunk of material, and we actually had this flipped upside down, and it actually pulled out of the vise. I think the first couple of times we had taken very light cuts, but if you're taking heavy cuts and maybe an aggressive feed rate, it may pull out of there because of this. What happened was this big chunk on the side curled up and the face mill caught it and pulled it. So the solution number one was to take less depths and slower feed rate. But we came up with a little bit better solution so we wouldn't slow it down too much and risk the pullout. If we can cut off these big chunks beforehand, that would actually improve our chances. Probably a couple different ways you can do it, but let's do it a real simple way with 2D contour. I'm going to go 2D contour. I'm going to pick a tool from Operation 1. I'm going to use my end mill, my 3/8 end mill. Select. And this will have all my feeds and speeds from Operation 1, so I shouldn't have to update that. I actually could have duplicated an operation too, but let's go with this one. Geometry selection. We want to get this big shape out here. And you got to see if it actually has been defined as having a chamfer on it. If it doesn't, we can just go right to that triangle. Now, where you pick this is kind of important because it could mean where this enters into play. But I notice it's on the left side going around, so I think this will work out well. Height commands. On second operation, I'd like to be in reference to stock top until we remove the top. We have extra material there. I'm going to go stock top and selected contour. On selected contour, or I could use model top. Model top would also work. And we're going to go just a little bit below so we get cut all the way around. So in this case, I'm using model top as my setup position, which would be X, Y in the middle, and we have a predefined Y-axis selection on this one, and X will be in the middle, and Z would be the top of the finished part. It's 750 thick. And I'm going to put in, back to tab 4, we're going to put stock to leave on. I'm going to turn this off, move this up. We're going to leave 0.025 of material on the outside and going to go to full depth on the depth because we're cutting through. Hit OK. And see what we got here. Up here, this entry is probably a good entry. I would not want to enter up in this corner because this is where it's very heavy material. We have to move this operation. We got to make it the first operation, so I'm going to move it right to here. Okay, I don't need to renumber the tools because they'll be aligned for my first operation. So if I'm doing both operations at once, like this is my G55 Vice 2 side, it should be ready to go. Let's do a quick simulation. And also on my setup, tips and tricks. You can use stock model for second side, but I found this works pretty good. We use the same side dimensions as operation 1, that'll get us a square. We used what was 230 on the bottom is now 230 on the top, and we just cheat this number here, negative 750, and that gives us a pretty good representation. And on this side, we're going to use WCS number 2. We already had that set up, which is aligns to G55, and I got my program already labeled 4M, my initials, operation 2, and different program number. I'm going to hit OK and simulate. Let's watch full simulation this time, and I'm going to turn on my operation. Okay, that's a good entry point. Coming around, this slug will chop off, this will chop off, and then we can go face milling and not risk having the part pull out. This can also apply to the 7M because there's a big piece of material hanging off. Depends on how you hold it. If you're holding it in a vise, it could pull out. If you're using like Mighty Bites inside the holes, I think that would still be a good grip. Alright, so we just go down and just chamfer. So later on we're going to get into engraving, so we can do engraving and build it into our program. But this would be a pretty good solution for cutting off the Exeter thick material on the sides. And that's about it. So we're going to utilize contour, stay outside the boundary a little bit so we're not going to cut into the finish area. And just to review our soft draws on this side, these are our soft draws. I'm going to pull these up. And I'm going to do top view. Top view, spin it. We made the soft draws. So this was our cutout and our spacer here. And I'm going to go to the blueprint that we made. So out on the shop floor, yeah, come on, open up. No, I'm getting an error. Okay. Anyway, we got a shop document that describes where we're going to the middle of the jaw for X0, and there's a known distance that we engraved on the top, and I'll probably add it to this program. It's Y minus 1.25, and the Z0 will be based on where it's sitting on the bottom, which would be sitting on the bottom and probe the bottom and move the coordinate up 750. That'll align with our work coordinate. Okay, that's about it. Talk to you later.